This conference will now be recorded.
That's when it receives its name. So if it develops to the east of 140 West, that's in the area of responsibility for the National Hurricane Center, and it will receive a name from the Eastern Pacific List. So if that system receives a name from the Eastern Pacific List and it continues to travel west across the 140 line into the Central Pacific area of responsibility, it will continue to keep its name. So it's kind of like when I was giving a presentation to the children, I would say, if you moved from California to Hawaii, would you change your name? So same thing with the systems over by that come from the Eastern Pacific into the Central Pacific. They keep their name that was given to them where they developed, which basin they developed in. So if a tropical disturbance or tropical depression develops into a tropical storm in the Central Pacific Basin, which is 140 degrees longitude to 180 degrees longitude, or the date line, it will receive a name off the Central Pacific Hurricane List. And so these are the names that we have for 2020. The East Pacific List will always start with an A and then follows down alphabetically, and it will alternate between a girl name and a boy name. And then those lists are reused every 6 years. So I've marked off Amanda, Boris, and Christina right now because those have already been named this year in the Eastern Pacific. Now the Central Pacific List is a little bit different. There's 4 lists, and they don't change lists year to year. So last year we had a system named Emma in the Central Pacific that was near the northwestern Hawaiian Islands. So this year, the next name that they would start with is Hone. So if we see one tropical area develop into a tropical storm in the Central Pacific Basin, it would receive the name Hone. If we saw another one this year, it would receive Iona. However, if you only saw the one this year and then we didn't see any more develop in the Central Pacific Basin, in 2021, the next name on the list would be Iona. So it's a little bit confusing, but this is where they derive their names from. So now let's look into the 2019 season that we had last year. So we kind of say that we had 5-ish storms within the Central Pacific Basin. So we'll start with Barbara, that was in early July in 2019. While Barbara never officially crossed into the Central Pacific Basin at that 140 degrees west longitude line, we'll talk about her because it got the attention of the Central Pacific Hurricane Center to start ramping up their hurricane forecasters. And it also did bring a fair amount of high surf to the east-facing shores, and the remnant moisture did track across the islands and brought heavy rains to the Big Island and Maui. So then the next one we saw was Eric. This one crossed into the Central Pacific Basin and was actually the only hurricane that we saw within the basin last year. So it was pretty well behaved, though. It stayed far south of the islands. It did bring some heavy rain to the Big Island and even Kauai as it stayed far south. But a thing to remember, if the center of the storm is where these lines are, the showers and thunderstorms and strong winds can extend well beyond where the center goes. So as Eric was passing to the south of the islands, those outer bands and moisture around the system were getting trailed or drug across the islands, across the Hawaiian Islands here. And so then that brings us to Flossie in the beginning of August last year. So Flossie is our favorite name, we like to say, in the Central Pacific. It comes off that Eastern Pacific list, and so those reoccur every 6 years. And it seems like Flossie always likes to make an appearance near the Hawaiian Islands every 6 years. So if you've been here for a while, you probably are thinking, well, I've heard Flossie quite a few times. So they haven't retired this name because it hasn't really provided enough, or it hasn't produced enough impact or enough damage to retire the name. So that's why we see it every 6 years. But for Flossie last year, it weakened to a depression near 150 west longitude. And so it produced high surf along the east-facing shores and then remnant moisture enhancing rainfall as whatever was left over of it passed to the north of the islands. So then that brings us to Oconee. This Oconee is a Hawaiian name, so that means that the disturbance area developed into a depression and then into a tropical storm within the Central Pacific Basin. And for Oconee, it didn't do much, didn't bring too many impacts, actually really any impacts to the Hawaiian Islands, as it was a very short-lived system, short-lived and weak system, only maxing out at tropical storm strength. Then that brings us to Kiko, another one from the Eastern Pacific. Kiko is a little bit weird, as in last year's total count did count Kiko as a system in the Central Pacific, but reanalysis earlier this year showed that it weakened right before reaching that 140 west longitude line. Kiko was an interesting one. It ramped up really fast farther in the Eastern Pacific, and then as it made its way closer to the Central Pacific Basin, it weakened really fast and then meandered in this, moving northwest, then moving southwest, moving northwest. You can kind of see at the end of this image, a little snake-like feature here, showing just Kiko meandering as it was in a weakening state. And then finally, this brings us to our last system, Emma. This one also was a system that developed in the Central Pacific, so receiving that Hawaiian name from the Central Pacific list of names. And this developed well to the southwest of Kauai. It became a tropical storm and then weakened near the northwestern Hawaiian Islands, providing very little impact to the main Hawaiian Islands. So that's why we like to say we saw about 5-ish tropical cyclones, with Barbara and Kiko being borderline ones right along that 140 west. And so our annual tropical cyclone count on average is usually between 4 to 5 systems. So last year fell well within that average that we saw. Things to point out here, 2015 saw 16 systems in the Central Pacific Basin. This correlates with an El Nino year. Same thing with 1997, 1992. 1992 is when Aniki hit Kauai in September. And these years all correlate with El Nino years. So El Nino is a warming of the Pacific Basin. And in the Central Pacific, we'll generally see more systems when we have warmer waters. So warm waters is one of the main ingredients for tropical cyclone development and life and sustainability of the tropical cyclone. So last year's seasonal outlook, we were saying that there were 5 to 8 tropical cyclones. But now if you remember that we only saw the 4 to 5-ish cyclones in the basin, you'll say, well, your prediction was you were on the lower end of your prediction. And that's because we thought that we were going to see an above normal season, because we had forecast El Nino conditions continuing. So that would mean El Nino conditions, warm the ocean temperatures, and then also it has El Nino does play an impact on the wind shear that we see across the island. So that was the wind shear last year was also projected to remain below normal. So you might ask, well, why did you think that the season was going to go that way? Because when the outlook was put out earlier in the year last year, there was a trend of El Nino increasing. And by the time we got to spring, it was increasing. But by the time we got to summer, it had started to flatten off. And then actually by the end of summer, we can see here that the El Nino index was showing that El Nino is actually turning into more neutral conditions. So El Nino is described by a 0.5 degree warming of the waters across that Pacific Basin area. And then La Nina would be a 0.5 degree cooling of those waters. So that takes us into what we're seeing right now. On the left-hand side of the screen, you're going to see the sea surface temperatures from April up until just about a week or so ago. And then on the right-hand side of the screen, you're going to see the SST, the sea surface temperature anomalies, or the changes from normal there. And one thing that we'll point out is that in the area that we're looking at is the equatorial Pacific waters. In the blue, you're going to have cooler water. So what we're starting to see from April through now is that there's a definite cooling along that equatorial Pacific area. This is also being shown in the anomalies by the the blue temperature showing that there are definitely cooler waters across this region. So from the early July Climate Prediction Center official probabilistic ENSO forecast, it actually changed from being in an ENSO saying that we're in a neutral condition to now moving into a La Nina watch. So a La Nina watch is saying that conditions are looking favorable for La Nina to develop in the next 6 months. So what we're seeing here across the bottom is the season, and then the probability going upwards on the x-axis. So currently, we are in a neutral state, but they're thinking that the probabilities for neutral will be decreasing as we move through the year, and the probabilities for La Nina are going to be increasing through the year. So there's about a 50 to 55% chance that we'll see a La Nina pattern take over by the fall to winter months. So then this brings us to the 2020 Central Pacific hurricane season outlook. This year they went with 2 to 6 tropical cyclones with a 75% chance of near to below normal season. And so when this outlook was put out at the end of May, that was still an ENSO neutral likely with a higher chance of neutral conditions staying. But now that there's a higher chance of La Nina transitioning, we'll likely see less on the lower end of the range for tropical cyclones. So when the outlook was put out, though, they did have a higher uncertainty of what was going to be happening with that La Nina. But again, we need to remember that this is the range for the whole entire basin, that area between 140 west and the date line. And so it doesn't really address any potential impacts to Hawaii. And if we only see 1 tropical cyclone or 2 tropical cyclones within our basin, and that one hits Hawaii, then we're in trouble there. So I can take this time right now to stop for just a second before we get into what is already occurring in 2020. If anyone's got any questions, you can type them in the chat. Or I believe you can unmute yourself and ask away. All right, well, I'm not seeing any questions come into the chat. All right, here we go. I see one now. So from Charla, is Oahu at more risk of being hit by a cyclone than the other islands? No, I mean, all the islands have the same risk of being hit by a cyclone. You could say Big Island just because of a majority of the tracks are coming from the east to the west. That Big Island sticks out the farthest or is closest into that eastern area that they potentially may see more of the impacts from them. But all of the islands are at a risk of seeing a tropical cyclone hit. All right, so thanks for that great question, Charlotte. We'll move on to what has been happening in the 2020 season already in the Eastern and Central Pacific. So up here are the tracks of the different tropical cyclones that we've seen since the beginning of the season. Actually, this is Tropical Depression 1E. Again, if you see anything that has a number like 1E, 4E, 6E, this means that these only made it to tropical depression phase and never became stronger than that. Otherwise, if they had reached the tropical storm strength of 39 miles per hour or greater, they would have received a name. But so Tropical Depression 1E developed in late April, and this actually marked the earliest seasonal start for the Eastern Pacific. So the Eastern Pacific season starts May 15th, but Tropical Depression 1E developed at the end of April. Now the Central Pacific hurricane season starts June 1st. There's about a 2-week difference in that because a lot of our systems are generated off of the Eastern Pacific waters, that area to the west of Central America. And so from 1E, then we saw Amanda develop, Tropical Storm Amanda. Tropical Storm Amanda was interesting as it developed and moved quickly into the Yucatan Peninsula. From there, it became a remnant low, and it was considered no more a tropical cyclone at that point. And then a little bit later, what was left of those remnants actually then reemerged and became tropical cyclone Cristobal in the Gulf of Mexico, and we'll show that in just a second. And so for us in the Central Pacific, we've only seen one system cross into the basin now, and that would be Boris. It crossed into our basin as a tropical depression and had only about 4 advisories in our area. It was a weak tropical depression when it entered and quickly became a remnant low once it crossed into the Central Pacific area. And then Christina was one of the more recent ones. It died off pretty quickly once it reached higher latitudes. The higher the storms go, the quicker they usually die off, because once they go higher in latitude, the waters get too cold for them. So tropical cyclones generally like waters that are at least 80 degrees Fahrenheit or warmer. But this weekend, we should see the remnant of Christina passing well to the north of Hawaii, which will help to cut our winds off a little bit. And now just to show what's been going on in the Atlantic basin, like I talked about earlier, here's Cristobal towards the left-hand side of the screen over the Yucatan Peninsula, then going up through Louisiana. So Cristobal, really the remnants of Amanda, then reemerged to become Cristobal for the Atlantic basin. And so the Atlantic basin they also started pretty early. Their season again starts June 1st, like ours does. But they did see 2 systems prior to that June 1st start date. So they ramped up pretty quickly with the beginning of the season, but have then now been on a slower trend right now. But for them, during La Nina phases, they generally see more tropical cyclones while we see less. And then that flips for El Nino, while we'll generally see more tropical cyclones within the Eastern and Central Pacific basins during El Nino. The Atlantic basin will see less. All right, so we can take any more questions that we have before we move into the overview of the Central Pacific hurricane products. So Jared asked, is there a particular most accurate model of tracking storm or hurricane tracks? So there's a lot of different weather models. There are models, and then there are specialized hurricane models. And so each one of these models has a different physics package associated with them. So their initial conditions will start off just a little bit different, and how it trends forward is just a little bit different. And so it's hard to say if one is better than the other, because each tropical cyclone will perform differently within each model. And so that's why we like to look at all of them, and we like to look at the trends of what's happening. Is one model performing well with this system, or is one model performing well with a different system? And that's another thing when you look at the spaghetti plots that people say with all of the squiggly lines everywhere. That's really to help us determine if the models are performing well or not. If we see the spaghetti lines all pretty closely packed together, then we can say, okay, the models are performing really well on here, or we have a higher confidence in our forecast. If we see like one going off to the east, one going off to the west, one doing a loop-de-loop, then we're gonna have a lower confidence in our forecasting due to the lower confidence in what the models are thinking. All right, so we'll move forward with an overview of the Central Pacific hurricane products and some of the new things that they have for this year. So one thing that the Central Pacific Hurricane Center starts issuing on June 1st is the Tropical Weather Outlook. So this is issued every 6 hours at 2 a.m., 2 p.m., 8 a.m., and 8 p.m. And this is going to include any areas that are of interest to us, any areas that we think in the next 2 days or 5 days could potentially develop into a tropical depression or greater. And so it comes in two formats. It comes in this text product that you see on the left-hand side of the screen. And then it also comes in this graphical view. So the left-hand side of the screen is going to show the 2-day graphical outlook. And the 2-day is just going to have an X on that area of interest with the formation chance on it. Anything in yellow or 40% or lower is considered a low chance of formation in the next 2 days. Anything that would be in orange between 40 and 60% would be a medium chance of development. And anything in red for 60% or greater would be a high chance of development. Now, on the right-hand side of the screen is the 5-day graphical outlook. On the 5-day, this hatched area isn't a track or a forecast. The hatched area, although in this case it looks like one, in this hatched area, this is telling us somewhere in this area over the next 5 days, we potentially think a tropical cyclone at that tropical depression strength or greater will develop. And it follows the same yellow, orange, and red with the low, medium, high chances of development. So the next thing that the Central Pacific Hurricane Center will also put out is the error cone. And these graphics are produced once that system reaches the tropical depression stage. And so there's multiple options on the website for looking at this track graphic. It is, there's going to be either a 3-day or a 5-day forecast. You can either turn the track line on or off, and you can either turn the current wind field on or off. And that current wind field is going to be this yellow area here. The yellow area would mean the extent of tropical storm force winds. And then if you saw a darker red area or darker orange area, that would be the extent of hurricane force winds. We generally like to show people this error cone, the track and error cone, without the track line on and just with the points. Because as we get to in the next slide, this error cone is really just showing us that 2 out of 3 times within that area, the tropical cyclone center will fall within there. But then there's a 1 out of 3 chance that it will fall outside of the circle. So the error cone is derived from finding that error at each forecast point over the past 5 years of tropical cyclones in both the Central Pacific Basin and the Eastern Pacific Basin. And so we have to use both of the basins, because if we only use the Central Pacific, we wouldn't have enough data to be significantly, statistically significant, right? So that's why we incorporate the Eastern Pacific Basin with us, so we have a greater count, so we get a better result out of our error cones. And so what is done after they find the error for each of those points over the 5-year running mean? Then you just draw the lines connecting the circles, and that's how the error cone is derived. And so really that means like I said earlier, is that 2 out of 3 times the center is going to fall somewhere within the cone range. But you have to remember that also means 1 out of 3 times that center point will be outside of the circle. We don't like people to focus completely on the track, because the forecast tracks are ever changing, and that the extent of the impacts can extend well beyond the center of the storm. And so from last year, or from the last 5 years, what we can see is that there's been really little change in the radius size of the error, or the error size at the points through day 2. But what we like to highlight is that at days 4 and 5, that there has been a pretty significant change. So that means that the forecasting over the past 5 years has improved, especially in the long term. So something that you'll see here is that what the new is that we have now added a 60-hour forecast point giving you a forecast point every 12 hours through 72 hours, opposed to what we had from last year and the several years before, where you only had the 12-hour forecast through the 48 hours. And so this new 60-hour forecast point will include the position and the intensity, as well as the 34 and 50 knot wind radii. It's also going to be used in the cone graphic that we were showing earlier, and then what I'll be showing in just a second, the wind speed probabilities. But so this 60-hour point is important, especially as we saw in 2018 with Lane. The 60-hour point would have given us a better idea of where we think that that turn would have occurred. So right now we just have between 48 and 72 hours. If we did have a 60-hour point, we may have been able to tell if it was a little bit, if that turn was going to be closer to the islands or farther away from them. So before we get into the wind speed probabilities, are there any questions on the track and error cone graphic? All right, well, I've not seen any, so we will move on to our wind speed probabilities. So these are produced for all of the systems that advisory packages go out for. It comes in a graphical form, which you see on the left-hand side, and then a text format, which you see on the right-hand side. And so the wind speed probabilities is going to show you the cumulative probability over 5 days at point locations. And so it will show you the probability of tropical storm force winds at a point location, or it'll show you the probability of the 50 knot winds or strong tropical storm force winds at a point location. And there's also one graphic for the 64 knot winds, which would correspond to the hurricane force winds at a point location. So we like to tell people it's a point location, and you can't just say that along the South Shore there's going to be a 40% chance of seeing tropical storm force winds in the next 5 days, because that would be an incorrect way of describing the statistics behind it. So you would have to find your point location and say, at this specific point, there is the 40% chance of tropical storm force winds over the next 5 days. In the text graphic, in the text product, I will point out, it does separate this. I cut it off on the top, I'm sorry about that. But there are times associated with these 12-hour time blocks associated with these columns here. And then the number in the parentheses would be that cumulative number. So at the end, this would be over the next 5 days, there's a 47% chance of seeing tropical storm force winds at South Point. But let's say this is Thursday between 12 a.m. and 12 p.m., there's a 14% chance of the tropical storm force winds. So I know that product's a little bit confusing. I hope I didn't confuse you guys too much on it. But this run is how those those wind probabilities are derived. So they use something called a Monte Carlo simulation, and they run the forecast 1,000 times with different forecast parameters in it to see how that's going to go. And this is where they derive those probabilities from. So when we're saying that there's a 47% chance tropical storm force winds over the 5 days at South Point, that means that 470 times out of those 1,000 runs that there were tropical storm force winds within that 5-day period. And so another thing that they are doing this year is that those tropical storm force winds used to be run with a climatological radius of a tropical cyclone, so just using a standard tropical cyclone size. But this year, they'll actually be using the wind radius off of the actual forecast. And so we can see on the left side of the screen, this is the wind probabilities that were produced for Hurricane Lane in 2018. And then in the middle, this is what they would have been using if they were doing it this year, with the radius being run off of the actual size of the storm. And what we can see is that it improves the actual it improves more of what you're likely going to be seeing for the islands, right? So you can see that there was a decrease actually in the wind speeds there, using the real size of Lane over the climatological size of a tropical cyclone. So other areas where they saw this really improve was something like Sandy in 2012, where Sandy was a really, really large storm. So using the average size of a TC didn't provide good information because it didn't really show the extent of the wind field across the region. Or opposite, Hurricane Dorian last year was a really small system. And then so the wind field, the tropical cyclone wind probabilities it was too large of a field for it, and it was showing greater probabilities farther out across Florida than what was really going to occur. Another thing that they've also updated with the wind probabilities is that they've improved the land and sea tables, and so won't see as many weird chop outs across the islands as we were seeing over the past couple of years. So on top of those wind probabilities, you can also overlay the earliest reasonable time of arrival and the most likely time of arrival. So this goes back to that Monte Carlo simulation, and the earliest reasonable means that 10% of those runs had tropical storm force winds starting at the given time. And then the most likely would be that 50% of the runs had those tropical storm force winds starting at that given time. So we always recommend to use this as your safe zone when you need to have things done by. The 10% is if you have a very hard deadline, which would be the earliest reasonable, and then the most likely would be if you have a little bit more fluid of a deadline, with that 50% of the run showing the tropical storm force winds starting at a certain time. And then we'll go over our watches and warnings. So a hurricane and tropical storm watch and warning definitions. The watch means that conditions are possible somewhere within that area. And then a warning would mean those conditions are expected somewhere within that area. Again, the watches and warnings really only cover or are put up based on the wind speeds of the storm. So if you put up a tropical storm watch, that means conditions are possible somewhere within that tropical storm conditions, so that 39 mile per hour to 73 mile per hour winds are possible within that area. And then for hurricanes, same thing, but with the wind speeds of 74 miles per hour or greater. So the timing goals on those, for a watch, we generally like to put those up 48 hours ahead of that onset of tropical storm force winds. And then the warning goes up generally 36 hours ahead of those tropical storm force winds. So we say generally because we don't like to put up any changes to the watch warning regime or put up any new watches or warnings at the 11 p.m. time frame. So the advisory packages from the Central Pacific Hurricane Center go out at 5 a.m., 11 a.m., 5 p.m., and 11 p.m., or every 6 hours. And so we don't like to do any of the changes to the watch warnings or add any new watches or warnings at the 11 p.m. time frame, because a lot of people will be asleep at that time, and there's really no benefit of putting it up if people can't act on the watch or warning that's going into place. So you may see a 12-hour buffer within that 48 hours or 36 hours, just based on what we think is more beneficial to the community in preparing themselves. And so this year, I believe last year too, the website is hurricanes.gov to find all of these products. And so it's become a unified location for both the National Hurricane Center, which is located in Miami and covers the Atlantic Basin and that Eastern Pacific Basin, and the Central Pacific Hurricane Center, which covers Hawaii and then that area of 140 west to the date line. And so you can get there by going to hurricanes.gov, or to have the Central Pacific page specifically pop up, you can go to hurricanes.gov/CPHC, but also weather.gov/CPHC will take you to that main page. And they did this because it provides better reliability, better load balance. And then there's also that seamless handoff at 140 west, from when the systems are in the Eastern Pacific to moving into the Central Pacific. All of the information can now be found on one website. So if we've got any questions at this time, we can take them. If you can unmute yourself or put it in the chat. All right, I see one coming in from Richard. Do you share forecasts with the Joint Typhoon Warning Center on the military side? Are your forecasts independent? Richard, this is a really great question. So within the Atlantic Basin, the Eastern Pacific Basin, and the Central Pacific Basin, the National Hurricane Center and Central Pacific Hurricane Center are the official forecasts, and JTWC will take our forecasts and just repackage them into their format. So in the Western Pacific, beyond 180, west of 180 west, and then south of the equator, JTWC is responsible for those forecasts, specifically for Department of Defense operations. There are what we call regional specialized meteorological centers. There's one in Nandi, Fiji, and one in Japan, in Tokyo. And so those are the official tropical cyclone centers for doing forecasts, but JTWC provides their own forecasts for Department of Defense operations for the South Pacific and the West Pacific. So we have forecast offices in American Samoa and in Guam, and they work closely with JTWC on providing any typhoon in the West Pacific or cyclone watches and warnings for the South Pacific. So Richard, it's with those heavy rains that we received back in April 2018, it's kind of hard to say exactly if that specific set of storms is attributed to climate change. But what we do know is that warmer waters will release more moisture into the atmosphere. And the more moisture you have available, the chance for getting a more flooding type system will go up. So moisture is the key ingredient for weather. So if you have more moisture available, the chances for getting more weather can be there. So I can't speak specifically onto what happened in Kauai in 2018. That's just a one system, but overall, if you see more moisture, the potential is there to see more weather systems go through. A recent study did just come out from NCEI, which is the National Center for Environmental Information, and they have gone back through, I believe, about 50 years of tropical cyclone data, and they are saying now that they believe there is a good correlation between the warming trend that we are seeing and the intensity of tropical cyclones. So Ahmad is asking, are we generally expecting a relatively quiet year? So we are. That's why our outlook numbers were lower on that 2 to 6 range instead of, edging higher to say 4 to 6 or 5 to 8. That's because of that La Nina taking over. When we see La Nina conditions developing in the Pacific Basin, that generally means that we're going to see less tropical cyclones. But that doesn't mean we're not going to see any, or that we're going to see, it only really takes that one. If we see 1 or 2 in the basin and that one hits Hawaii, then that's what's going to impact us. So Lily asks, what is the peak month of hurricane season? So the peak months for the Central Pacific hurricane season is the later summer months between August and September. And this is generally when the ocean waters are the warmest around us. All right, so I just have a couple more slides. I was asked to speak a little bit on the COVID-19 pandemic and hurricane prep. So I pulled just a couple things. On the left-hand side of the screen, this is from ready.gov. And what they're saying is that if you must go to a shelter, remember that you need to protect yourself also from COVID-19. And this would be things to remember to bring with you are things like soap, hand sanitizer, cleaning products. Make sure you bring your masks and you maintain that socially distant, maintain that social distancing, especially when you're in the shelter, and try to only maintain your same family unit within the shelter. And then another thing that I can speak on is that HIEMA, the Hawaii Emergency Management Agency, has been holding regular calls with all of their ESFs to make sure that the state is ready and can implement social distancing measures at the shelters. And so they are going to try to follow the Red Cross guidelines of 60 square feet per person, 100 without a cot, 110 square feet per person with a cot. They are talking, though, that sheltering, it is going to be a little bit difficult. They think sheltering will be limited based on the and there won't be enough to meet the population demand. They are also expecting fewer volunteers this year, and they are going to try to screen everybody before entering the shelter. So that would mean filling out a questionnaire and doing the temperature checks and that type of thing. But the best thing to do is to check with the local officials, especially if a system does threaten, about the updated evacuation shelters, and that not all the shelters that were open last year or the year before may not be open this year. And then so these are just a couple handy websites. The Hawaii Emergency Management Agency website, and then ready.gov and FEMA.gov. Another thing you can do is just type into Google FEMA, and then type FEMA, then COVID-19, and then hurricane preparation. And in May, they came out with a operational plan. FEMA sent an operational plan out about what to do for this year during the pandemic. And so with that will conclude the presentation today. I'm really sorry that my webcam didn't work. If you have any questions, please type them in the chat now, or if you can unmute yourself, please feel free to do that. Otherwise, you can reach me by my email down there, or you can call me.
Thank you.
Yeah, no problem.
All right, thank you everybody for attending today's program. Please be on the lookout. We'll be having a program next month. And again, thank you, Leanne, for speaking today for our BOMA Hawaii members.
My pleasure. I hope you guys learned something. Also, if you have any questions, you can always email me.
Great, thank you again, Leanne.
All right, thanks. I'm gonna close out the meeting now. I hope everyone has a great rest of their week and good weekend.